Welcome to the University of Ottawa's Laboratory Safety Orientation. This orientation is designed to give facility workers, construction workers, and external contractors the information they need to work safely in laboratory spaces. Looking at these 6 photos, you might be wondering which are laboratories. The answer is all of them. As you'll learn in this orientation, laboratory spaces at U Ottawa come in many forms, each with their own equipment, risks, and safety protocols. No matter the setting, your role in these spaces helps support the university's research and teaching. This orientation includes general information about lab safety and is split into 3 main sections. We will review performing work in lab spaces, including key steps to take before, during, and after performing work in lab spaces as a non-regular lab user, emergency procedures, and recognizing laboratory hazards by looking at the different types of research labs at the University of Ottawa, an overview of their common risks and how to protect yourself. It is important to note that this orientation alone is not enough to enter all lab spaces safely and does not authorize unrestricted or unplanned access to labs on campus. We'll start by learning about the process to plan and carry out your work in labs. The first and most critical aspect of working safely in labs as a non-regular lab user is coordinating with the people who oversee the lab spaces and understanding their hazards. All work must be coordinated in advance to make sure that you receive site-specific training customized to the lab that you will be entering. You have the proper personal protective equipment, PPE, to protect yourself, and regular lab users can secure chemicals, experiments, and sensitive equipment. In general, coordination is a process that occurs between your University of Ottawa representative and the facilities manager of the building the lab is located in. This U Ottawa representative is your contact person and liaison. It could be a lead head, trade manager, project manager, planner, or other contact. You must be given their contact information and be able to contact them while you are carrying out your work. If you enter a lab without permission or if you don't follow the instructions you were given, you could seriously injure yourself, damage very sensitive and expensive equipment, and destroy research that has been in progress for many months or even years. Coordination is a key first step in preventing this. When you work in labs, you have the right to be informed of all hazards you will be or are likely to be exposed to. Before you begin working, you should feel confident in the safety measures put in place through the coordination process. When you're about to enter a lab, check if you can answer a few questions. Do you know what hazards you may encounter? What could happen if they occur? How they are being dealt with? What you need to do to perform your work safely? You have the responsibility to follow up with your supervisor or UO representative for clarification before you start working. As previously mentioned, determining the appropriate PPE is an important part of the coordination process. The necessary PPE will depend on the lab you are working in, the work you will be doing, and any other work being carried out nearby. Before you enter the lab, your supervisor must provide you with the proper PPE and tell you how to put it on, or don, and how to take it off, or doff. Before you enter a lab, take a moment to compare the PPE assigned to you with the posted signage. If you are an externally contracted worker, unless you are entering clean rooms, it is your employer's responsibility to provide minimum PPE, which we will review on the next slide. While you will receive more specific instructions, the minimum recommended PPE for lab spaces is very similar to that of the average lab worker. Every lab requires that you wear closed-toe shoes, have no loose clothing or jewelry, tie up long hair, and wear long pants and long sleeves to protect you from splashes or spills. In most labs, it is critical to also wear chemically resistant safety glasses and nitrile gloves. Other labs might require that you wear a safety vest, hearing protection, safety boots, a hard hat, or respiratory protection, among other PPE. During coordination, your thermal comfort will also be considered. You may have to work outside of a normal temperature range if you need to work in or near cold rooms, incubation chambers, autoclaves, although you should never work around an open autoclave during a cleaning cycle. If you need to work outside of normal temperatures, a plan will be put in place that may include modifying your work/rest intervals, how you will carry out the work, or the type of clothing or PPE you will wear. The activity of a lab, or how busy it is, also determines the PPE you must wear and the precautions you must take. Decommissioned laboratories, for example, are empty, meaning no lab members are present and there is no ongoing research. All surfaces and equipment are decontaminated. In contrast, an active lab with no ongoing research will have chemicals and lab equipment present and stored appropriately, decontaminated work areas, no running experiments, and no lab members present. Finally, an active lab has ongoing research with chemicals present on benches, lab members present, and lab equipment running experiments. Most of the labs on campus are active. Hazards such as chemical residue are much more likely the more active a lab is, but even when the room is expected to be decontaminated, there might still be a risk due to chemicals having made their way into hard-to-clean areas. Besides PPE, the coordination process will also determine whether you need to be escorted while you carry out your work. You may notice S&F restricted access signage on the top corner of doors, leading into certain spaces at the university. You must be escorted into any labs with this signage by an authorized representative of the space. This is to keep you, the equipment, and the work safe and secure. The letters also correspond to access to these rooms in an emergency. If a room is marked with an orange S, entry is forbidden, except in an emergency. Entry into rooms marked with an F and a red octagon is always forbidden, even in an emergency, unless escorted. Now let's see if you can put what you've learned into practice. Imagine you're about to enter a lab and you've done everything right so far. Your work has been coordinated. You're at the right place at the right time. You've been given specific training about the hazards present in this lab, and you have your PPE and know how to use it. You walk up to the lab and notice a sign on the door that reads, "Do not enter. Experiment in progress. Sensitive equipment." Pause the video and think about what you would do next. The best next step would be to reach out to your UO rep and confirm what to do. That's one reason why having their contact information is critical. We'll see more over the course of this orientation. Generally, before you enter a lab, you should review any signage present. Along with PPE information that you can reference, lab signage often has a floor plan with hazards highlighted in the positions in which they occur. After checking the signage, you should announce your arrival to any lab members present. Knock on the door, announce yourself, and wait for a response. Your arrival should not be a surprise. Introduce yourself to any lab members present and remind them of the work that you will be doing. Depending on your work, you may need to cordon off a work area or set up signage. As you work, it's important to be conscious of keeping the laboratory spaces secure. You have an important role to play in preventing theft, misuse, or intentional release of biohazardous, radiological, or chemical materials. Do not leave doors propped open as this disrupts the ventilation of the room and may invite people nearby to wander in. Keep doors closed. Some doors may also be alarmed. As you are carrying out your work, 12 general guidelines can help keep you safe and ensure you have minimal impact on the lab's activities. First, aim to cause the least disturbance possible. It's also important that you work within the hours arranged by your U Ottawa representative during coordination. Have ID and proof of authorization on your person in case your identity or your work needs to be verified. Absolutely no food or drinks, including water, are allowed in labs at U Ottawa. Leave any water bottles outside. This also extends to chewing gum, which is prohibited. Appliances such as fridges, microwaves, kettles, and hot plates present in the lab are strictly for lab use and likely used in experiments. In general, you should not touch or move anything in a lab. If you need anything moved, ask your UO rep or a lab member. You should also avoid putting your things on lab surfaces. Instead, bring a clipboard or a portable table. You should treat surfaces in the lab as though they are contaminated. Do not listen to music, as this can prevent you from hearing an emergency and helps keep contamination from touching your ears. However, do use hearing protection, such as noise-canceling headphones and earplugs, when instructed. Avoid climbing on lab benches, as they may be contaminated. If you must work above lab benches, bring a ladder. Planning is required when you work above lab benches, as simply removing a ceiling tile can generate dust. Neither dust work nor hot work should be carried out unless coordinated and planned. For example, hot work at U Ottawa requires a permit, a designated fire watch, and sometimes disabling smoke or heat detectors. Finally, all chemicals should be capped or stored away to protect you. As you are wrapping up your work, please note that you must capture, collect, and dispose of all waste that you generate. This includes debris, dust, and any hazardous materials created by your work. Any waste generated by contracted work must be disposed of by the external contractor. In addition, no liquids other than water, including suspended solids, may be poured down sink or floor drains. Failing to follow these guidelines can have devastating consequences for workers downstream and local ecosystems. Anyone in violation of this may be subject to fines by the Ministry of the Environment. Now that you know the general process for working in labs, let's take a moment to review what you should do when something seems off, or in an emergency. In case of spills concerning smells or alarms, leave the room and call protection services. They can be reached by dialing 5411 from any U Ottawa landline, 613-562-5411 from any phone. They are also easily accessible through the secure UO app. During your call, you'll need to give your name, the name of your supervisor or UO representative, the exact location, including the building name and room number where you need assistance, and the reason for your call. Available 24 hours a day, Protection Services is always there to respond when a member of the U Ottawa community is in need. Calling Protection Services will result in a quicker response than if you dial 911. They are familiar with the campus, can unlock doors and gates, and they will escalate and coordinate with 911 emergency services if needed. You might be wondering which lab smells are a cause for concern. In general, a variety of chemical odors are normal, harmless, and expected in labs. During coordination, you might receive details about the normal smell of a lab. You can also confirm with a lab member or escort as you enter a lab if you notice a smell. However, if, over the course of your work, you notice a new or unexpected smell, leave the room and reach out to a lab member or your UO representative. A few specific smells you should always escalate to a lab member or your UO representative include a sweet or almond smell, the smell of eggs, a fishy smell, a burning or melting smell, the smell or taste of metal, for example. If you're unsure, remove yourself from the room and reach out to a lab member or your UO representative. After your initial call, contact your supervisor and UO representative. You need to report all incidents and accidents as soon as possible or within at most 24 hours, including injuries, near misses, floods, gas leaks, property damage, and electric shocks. If something happens or seems off in a lab, advise the lab workers who are present as well. What may seem insignificant to you may have profound consequences on them or their research. Safety equipment is also available in labs and can be used in an emergency. When you enter a lab, take a minute to locate the emergency shower, eye wash, first aid kit, and spill kit. They should be easily identifiable, readily accessible, and not obstructed. A red button connected to the wall near safety equipment can be used in an emergency to increase ventilation and alert protection services. Use only in case of major hazardous spills, fumes, or a medical emergency, and avoid pressing if any equipment is under alarm. If you need to use the emergency shower due to being in contact with or splashed by a chemical, pull the handle to release water. For an eye wash, remove any eyewear or safety glasses. Press the lever to activate the water stream, and lower your head to flush out both eyes. You may need to use your pointer and index finger to keep your eyes open. Whether you use the emergency shower or the eye wash, rinse for 15 minutes. Afterward, seek medical attention. If you notice a chemical spill, alert everyone in the lab immediately. Leave the room and close the door behind you. If there are lab members present, they might respond to the spill themselves using a spill kit. These kits are typically found near the entrances to labs. If there are no other lab members present, call Protection Services. In either case, contact your UO representative for guidance on what to do next. If you encounter a fire in a lab, you should alert others, pull the fire alarm, exit the building, and call protection services. You also must notify your supervisor. You should only attempt to extinguish a fire that was created because of your work or equipment, and if you are trained and have assessed that you can safely do so. Do not attempt to control fires in other parts of the lab or those involving unfamiliar materials. In the case of hot work, follow the plan created during coordination. If you are required to bring your own extinguisher to the lab, such as during contracted or hot work, it should be a carbon dioxide extinguisher, as it is the least likely to damage lab equipment. Now that you know who to reach out to in an emergency, and have a better understanding of the safety equipment in laboratories, we will look at different lab environments at the University of Ottawa, their hazards, and how to stay safe. As a reminder, this is intended to be an introduction. Many labs will require additional site-specific safety training. In this section, we will review hazards in labs more broadly, including hazardous materials, how they are transmitted, and basic controls to minimize their impact, as well as biohazards and their controls, cryogenic fluids, electrical hazards, and mechanical hazards. Then we will look at a few unique lab environments, including engineering labs, radiation in labs, greenhouses, autopsy labs, and animal care and veterinary service laboratories, finishing the orientation with a key summary. Hazardous materials, as denoted with pictograms, are present in labs. WMIS training is required for you to enter laboratory spaces and understand these pictograms. Because your presence in a lab is coordinated, hazardous materials should all be stored and locked away for your safety. If you see dust, powder, or liquid on any surface, report it and do not touch it. It might be a hazardous chemical. Treat any unknown materials as if they were hazardous. Be aware that labels on small chemical bottles might not have the red diamond symbols because of WMIS labeling exceptions. Because of this, you should not touch anything, even if it is labeled as something that you might use, like a cleaning solution. Alert a lab member or a UO representative if you need something in your work area moved. Even though we recommend wearing gloves, make sure to wash your hands and work clothes regularly and dispose of used PPE, such as gloves. This level of caution is advised because of the methods of transmission. Being near chemicals alone will not hurt you unless they get into the air that you breathe, onto or into your skin or into your eyes or mouth. You can accidentally ingest hazardous materials if you skip washing your hands after exposure to residue. Inhalation can occur through breathing in fumes and other vapors. Skin and eye absorption can occur due to spills, splashes, and unintentionally touching surfaces. And finally, accidental injection can occur from a puncture from an uncapped needle, syringe, scalpel, or other sharp contaminated instrument. By coordinating your work, your exposure to hazardous materials is minimized, but you must also avoid touching surfaces and moving chemicals or equipment in labs. Special consideration in labs should also be taken around compressed gases, flammable materials, and corrosive materials. In U Ottawa labs, compressed gases should be secured to the wall, either with a chain or individually. When they are not in use, they should be capped. The specific gas itself might have additional hazards. For example, flammable gases and oxidizers need to be stored separately, because together they can lead to fire and worsen that fire significantly. Coordination in this case is especially critical if you need to bring hazardous materials into a lab to complete your work. Gas cylinders must be moved away from flames and hot work because they can explode. Gas sensors might be present in labs to monitor air levels. If these go off or you suspect a gas leak, alert others, leave the room and call protection services. Secondly, flammable materials form vapors that can easily ignite and burn at normal temperatures. While they are often kept in flammable storage containers, they must be moved if any hot work is done nearby. In the event of a spill or a fire, it is important that you turn off all your equipment, especially electrical equipment or anything that can generate sparks, heat, or flames. Finally, corrosive materials, such as acids and bases, are present in many labs and can cause serious chemical burns. While they should be stored away during your work, it is important not to move them yourself. When acids evaporate, they can leave behind a salt-like residue of very concentrated acid on bottles and surfaces. Even a small amount or low concentration of acid or base left on clothing can evaporate over time, become concentrated, and cause serious burns. If you are exposed to corrosive materials, move to the shower, sink, or eye wash as quickly as possible and rinse for 15 minutes. The longer the chemical is on your skin, the worse the injury will be. Finally, if you are working in ceilings or near sinks, be cautious around glass pipes as they contain acids. One way to reduce the risk of exposure to hazardous materials in the laboratory involves engineering controls such as fume hoods, exhaust arms, and glove boxes. They are designed to protect both occupants from the materials and sensitive experiments from the occupants. Of the three, fume hoods are the most common. These have a sliding protective sash. To keep chemicals contained, it should be fully lowered. Report any open sashes near your work area to a lab member or your UO representative. Do not attempt to close them yourself. All three of these pieces of equipment may be alarmed. Alarms signal that these are not functioning properly and that you might be exposed to the hazards they are trying to control. If you work around this equipment, be sure to report any alarms, uncapped chemicals, or anything that needs to be moved to your UO rep or protection services. Some U Ottawa labs work with biological materials like bacteria, viruses, fungi, and parasites, which can pose a risk of infection. In these labs, it is important to protect both people from infection and research material from outside contamination. Always read signage posted at the lab entrance to make sure that it matches the instructions you have been given. Be aware of hazards such as needles, syringes, open flames, and contaminated surfaces. Avoid touching surfaces and anything in general. If you need to work in these spaces, coordination beforehand will ensure that you have the correct PPE and entry procedures to work safely. These labs also use control measures to keep biohazards contained, such as biological safety cabinets, biohazard waste/sharps containers, and clean rooms. Clean rooms are highly controlled environments designed to prevent contamination from dust, airborne organisms, or vaporized particles. They are used to protect both researchers and sensitive research material. Some tools may not be permitted inside or may need to be wiped down before entry. This helps prevent contamination from entering or leaving the space. Entry into clean rooms must be coordinated ahead of time. Entry procedures, including PPE and escort requirements, will depend on the lab's risk group and containment level. Cryogenic fluids are gases at room temperature that are cooled to the point that they become liquid. They are stored in dewars. These mostly hold liquid nitrogen and dry ice. Because cryogenic fluids are so cold, they can cause cold burns. Specialized gloves need to be worn to use these dewars. The large dewars will periodically vent through a pressure release valve and can be startling. If you are working near these dewars, be careful not to knock them over. If even a small amount of liquid is spilled, a significant amount of gas can be generated, creating an oxygen-deficient atmosphere. For the same reason, do not enter an elevator with a dewar. It could quickly become a confined space in the event of a spill. Glassware can be found everywhere in labs, on counters, stored on shelves, and in fume hoods. Be mindful of the movement of your body and equipment in tight spaces to avoid knocking over glassware and other chemicals. If glassware needs to be moved, a lab member should do so even if it appears to only contain water, or if it looks clean. In addition, broken glass should be reported to a lab member and the UO representative. Never pick it up yourself. When considering electrical hazards in labs, consider both the equipment that you bring into the lab and the equipment that is already there. Some labs have high-voltage equipment. Do not use the outlets found in labs unless you have received prior authorization. Battery-powered tools, when needed, are a good substitute for corded ones. The outlets and equipment have been specifically paired for the design of the lab and the circuit. You may notice red outlets in labs. These are for emergency power and sensitive equipment only. When using electrical appliances, they should be CSA approved with no in-house modifications. You should also ensure that any wiring you set up does not create a tripping hazard. In mechanical labs, there is a risk of injury from rotational impacts and linear movement from various lab equipment, including lathes, mills, drills, saws, and others. Do not operate or move lab equipment, even if it is something that you normally use. Keep your distance and maintain a clear perimeter around this equipment. If you are generating dust in your work, ensure you are aware of the plan in place to minimize the fire hazard this poses. Some of the most common machines in labs are vacuum pumps, which you might find on the floor. These should be placed in secondary containers because they can leak oil. If you are near equipment with round drive belts, make sure they are guarded. Report anything that seems off to any lab members present and/or your UO representative. In case of emergency, this equipment often has emergency stops, or red buttons, on the equipment itself. There are a few unique engineering laboratories at the University of Ottawa, including the pilot plant, which houses chemical reactors composed of distillation columns and vapor lines. Stay alert for surfaces that can get very hot or very cold. There is also combustion research on how mixed gases or wood chips burn. You must not enter these gas chambers during active experiments due to the risk of heat, flame, and gas exposure. Finally, students' spaces, like paint or exhaust booths, should also not be entered while in use because of the respiratory hazards posed by isocyanates and exhaust fumes. As in other labs, your work in engineering spaces will require coordination and you will need PPE, such as steel-toe boots, a hard hat, and possibly hearing and respiratory protection as well. Structures labs are another type of engineering lab. In these spaces, concrete, stone, or brick walls are built, tested, and demolished repeatedly. Pause the video and take a look at this picture. What hazards do you notice? You may have noticed rebar sticking out, stacked materials, concrete and silica bags, various tripping hazards, and possibly even a spill, to name a few. When entering these spaces, treat them like construction zones. Be mindful of your surroundings and look for hazards. Additionally, you will need specific PPE to enter these spaces, including a hard hat, safety boots, and safety glasses. Additionally, our hydraulics lab has a flume, or large containment of water, to test the flow of water and soil under various conditions. A flume can become a confined space, and the surfaces around it are slippery. If you need to work near the flume, you must follow water precautions. Working above the flume requires training on how to work at heights above water. Coordination is critical because it helps identify the types of training that you will need for your work. In Ottawa labs, X-rays and radioactive isotopes are used at low levels, within regulatory exemption limits. Even then, all radioactive sources and materials should be in shielded lead storage or behind a barrier, such as plexiglass, that encloses the radiation. Equipment that emits radiation should be either turned off or within its internal shielding and interlocking mechanisms. For X-rays, the hazard only exists if the machine is on. A light indicates that the X-ray machine is operating. Overall, you can stay safe in these labs by following signage and respecting shielding and defined work areas. You shouldn't need specialized PPE, but Ottawa has a radiation specialist on campus for any questions, inquiries about dosimeters, or further information. Nuclear magnetic resonance, or NMR, machines are superconducting magnets that generate strong magnetic and electromagnetic fields. In general, if you have been told that you cannot have an MRI, you should not work near an NMR or other strong magnet used in a research setting. These machines can interfere with pacemakers, insulin pumps, screws, pins, plates, and other medical implants. They can also damage or erase magnetic media, such as credit cards, and affect sensitive electronics. Hazard zones around NMR machines are clearly marked, typically with floor boundaries or non-metallic barriers. You must never cross these zones or enter an NMR lab without proper coordination or an escort. NMR and other magnetic systems are extremely sensitive and must not be touched. Calibration can be affected by vibration, interference, or unauthorized contact. One of the most important precautions is to keep all metal and magnetic objects away from the magnet. These items can be rapidly pulled into the magnet with dangerous force. Never attempt to retrieve an object yourself, as you can easily crush and injure fingers or limbs in the process. Instead, immediately contact the NMR facility manager. Additionally, strong magnets may be paired with other hazards. The magnets in NMR machines, for example, are cooled using cryogenic gases, and if a metal object strikes the magnet, it can release these gases, creating an asphyxiation hazard. Work in laser labs requires coordination and planning. There are different categorizations for lasers, with Class 3B and Class 4 being the most hazardous. There will be clear signage on the doors of these labs, including lighted signage. Never enter a lab if the illuminated laser sign is on. Accidental exposure to lasers can cause blindness and skin burns. Laser lab users need to wear safety glasses that block specific wavelengths of light. The laser equipment itself is also expensive and highly dust and light sensitive. For example, if dust lands on the optic, the beam could burn it in, damaging expensive equipment. Lasers require delicate calibration, and this could mean losing years of research. You must be escorted in these labs. During coordination, you will be informed of specific entry procedures, controls, and PPE. This might require cleaning equipment and changing shoes before entry, for example, to prevent dust. The university hosts several greenhouses, including a research greenhouse and a permanent collection. To protect the plants, it is essential to avoid cross-contamination. Certain microscopic insects or soil types can severely damage greenhouse plants. Therefore, you must not enter either greenhouse if you have recently been gardening or working with plants, including lawn care. A specific sequence and order of entry to greenhouse bays must be followed at all times. For example, you should never enter the Carey greenhouse if you have been in the bioscience greenhouse. As with other lab equipment and sensitive research, you should not attempt to move the plants on your own. All access must be coordinated in advance, and an escort by the greenhouse coordinator is required. The Faculty of Medicine's autopsy lab, located at Roger Gaindon, receives human donations for the education of medical students. They perform routine post-mortem examinations on deceased adults. You'll notice a normal but strong smell of formaldehyde in this lab due to the embalming process. Coordination is critical within this lab to ensure the privacy of the deceased and that no bodies are on display. Animal Care Veterinary Services, or ACVS labs, are registered research facilities that provide animal care and husbandry services to a variety of species, such as mice, fish, and bees. When entering an ACVS lab, make sure to consult any posted signage. Some of the rooms have animals completing behavior studies and are on reverse light cycles. A room with reverse light cycles are lit with red light. Red ink, either printed or from pens, will not be visible in these rooms. Work must be coordinated, since noise and vibrations that you produce while working can disturb sensitive animals or study conditions, even when outside the lab. Failure to follow communicated requirements can be detrimental to an experiment that could take months, if not years, to create. You will need an escort in these labs, and specific PPE. As a final note, safety is important. As you begin your work in labs at the University of Ottawa, stay aware of hazards, sensitive research and damage prevention, and know your contacts well. Hopefully, through this orientation, we've convinced you to coordinate your work. The coordination process is how you will get site-specific safety information to keep you safe. Additionally, do not enter labs without authorization or an escort. Take note of signage and hazards in labs. Do not eat or drink anything in labs, including water and gum. Do not move or touch anything. Ask a lab member or UO representative if you need anything moved. Consider everything, including surfaces, to be contaminated unless you are told otherwise. And finally, when in doubt, leave the lab and report anything that seems off or out of the ordinary. Congratulations on completing the lab safety orientation, and thank you for your work in supporting the research and teaching missions of the University of Ottawa. If you have any additional questions, do not hesitate to reach out to your supervisor, U Ottawa representative, or use the contact information below.